Today we're going to be working with locating numbers on a number line. Our title today is Locate Real Numbers. Real numbers, if you remember, are the set of rational and irrational numbers combined. So we'll be doing both of those, both rational and irrational. The objective is specifically I could plot irrational numbers on a number line. We'll start with some rational numbers and kind of get used to that, and then we'll work our way to some irrational numbers as well. So the introductory problem here says which mark below is closest to 3 5/7. So the first thing we're going to do is we're going to identify on the number line what we're counting by. It says identify each interval on the number line, and then we're going to fill them in. So this is pretty small and a little bit tough to see, but on your page, you can look on your page and see a little bit better what we're looking at here. So sometimes we're just counting by ones, sometimes we're counting by more than ones, maybe less than ones. In this introductory problem though, let's just start trying to count by ones and see if that works. So we start at 0 and just count by ones as we move our way this direction. So 1, 2, 3, 4, and 5. That seems to work with what we've got here. And if we count backwards, -1, -2, -3, -4, -5. So let's fill those in. You guys need to write these in too. So you'll write in -1, -2, -3, -4, -5. And again, that might be pretty small for you to see, but you know what you're writing there. So once we have our intervals filled in, and we do that so to make sure that we can see very easily and clearly what numbers lie on the number line there. The next thing we'll do is convert the number to a form that's easy to place. So the fraction, we might be able to figure out without too much trouble where that goes, but we're going to be converting our numbers to decimals today because decimals are a little bit easier to place on the number line. So we know our whole number is 3. This is 3 5/7. So you guys need to do this in this box here. We're going to change this using long division. So this is something we did earlier this year. The numerator goes on the inside, the denominator goes on the outside. Put a decimal point there. We got our whole number 3 that we already know goes there, and we can put some zeros in. Now we really only need 2 numbers after the decimal to place these on the number line well. Once we have 2, we're good to go. So 7 doesn't go into 5, but 7 does go into 50 7 times. So 7 times 7 is 49. We could subtract that, borrow from the 5. 10 minus 9 is 1. Makes sense. 50 minus 49 is 1. Bring down a 0, and 7 only goes into 10 once. 1 times 7 is 7. We're just left with 3, so we're good to go there. 3.71. So let's go ahead and fill in our intervals on this one too. So 1, 2, 3, 4, -1, -2, -3, and -4. Fill those in if you haven't done that yet. So now we're going to decide, and we're just going to pick between these letters that are here. There, decide which mark it's closest to and how close. In other words, if we're at 3.71, if we're at 3 something, we're going to be between 3 and 4. 3.5 would be exactly halfway between 3 and 4, but we've got 3.71 in fact. So that means that we're going to be closer to 4 than 3. Not super close, it's not 3.9, but if you look at your options here of what's available between 3 and 4, closer to 4, our only best option there is F. So that's the one that best fits where we're at here on the number line. So we're going to do some more of these, and some of these are going to go pretty quick, and some of them are going to take a little time for us to convert. But the first thing I want us to do, step number 1 today, is fill in our intervals here. So we take a look at this on these down here. Let's just try ones and see if that works. Not all of our number lines will be ones, but let's see if it works here. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So that seems to work, and it should work that direction too. So it looks like we're just counting by ones on this number line also. So let's go ahead and fill in 1, 2, 3, 4, 5, 6, 7, 8. And going backwards, -1, -2, -3, -4, -5, -6, -7, and -8. So make sure you got all that filled in. Okay. So we're going to go through each one of these. Some of these we'll need to convert and some we won't. Like for example, number 1 is 4.2. It's already a rational number. It's already in decimal form, in fact. So it's going to be pretty easy for us to figure out what to do because we don't have to convert anything. So 4.2 is between 4 and 5. There's really only one thing between 4 and 5 anyway, but it makes sense because it's closer to 4 than it is to 5. 4.5 would be exactly halfway between. 4.2 is going to be closer to 4, so F is your best option for that one. All right, number 2 is 0.55. Okay, so 0.55 is still positive, but it doesn't have a whole number. So it's going to be, if 0.55 is going to be between what two whole numbers? It's going to be between 0 and 1. So we look at our options between 0 and 1. 0.5 would be exactly halfway between because there's another number added on to it, 0.55. This is like 55 on our way to 100. So it's a little past halfway with that extra 5 there at the end. So D there makes sense for that one. So D is our answer. So we're just finding which one of those letters best represents where we're at on these number lines. All right, number 3 is 2 3/4. So this one is not written as a fraction, or it's not written as a decimal. It's written as a fraction. We can take 2 3/4 and use long division to change this if we need to, but you may know what 2 3/4 is. So think about that for a minute. Think what the decimal form of 3/4 is. If you can remember, it's like 3/4 out of 4 in a dollar. So it's 2.75, right? So 2.75. 2.75 is going to be between what two whole numbers? It's going to be between 2 and 3, but because it's 2.7 beyond 2.5, it's beyond 2.5, it's going to be closer to 3 than it is to 2. So we're looking at somewhere between 2 and 3, but closer to 3. So E is going to be your best choice there. All right, those 3 were pretty easy. We're going to get a little tougher with the next 3. Okay, number 4, move this up a little bit here. Number 4 is -5 8/11. -5 8/11. So this time we have a couple things going on. We got a negative number, and then we have a fraction that we're not really sure what the decimal form is yet until we change it to a decimal. So let's go ahead and use long division to change this. Numerator on the inside, denominator on the outside, decimal, some zeros, and bring our decimal point up. Our whole number is -5, and let's begin putting 11 into things here. 11 can't go into 8, but 11 can go into 80. Goes in 7 times. 7 times 11 is 77. When we subtract, we have to borrow from the 8. 10 minus 7 is 3, and 7 minus 7 is nothing, so bring down a 0. 11 can go into 30 twice. 2 times 11 is 22. And we subtract that, and we're left with just 8. So -5.72. Now, -5, think about that for a minute. What two whole numbers will -5.72 be between? Well, it's going to be less than -5, but not quite to -6, right? So it's going to be between -5 and -6. -5.5 would be halfway between -5 and -6, but this is closer to -6. Because it's -5.7. -5.9, we are right next to -6, but not quite to it. So this is -5.72. So A is your best answer on that one. All right, number 5, we're going to have our first irrational number here on this one. Number 5 is the negative square root of 18. Remember, you can't have a negative square root, so we know our answer will be negative. And you have 2 different methods here that we've worked on in class for finding the square root of 18. You can either use long division or you can use guess and check. So since we have just done long division, let's do guess and check. Why not? So we've got 18. We need the 2 perfect squares on either side of 18, which are 16 and 25. Take the square roots of these. So the square root of 16 is 4. The square root of 25 is 5. The square root of 18 will be between 4 and 5. So it's going to be 4 point something. Because we're only 2 away from 16, but let's see, 18, 25, we're 7 away from 25, we're going to be closer to the 16. So it's going to be something 4 point less than 4.5. It's not so close that 4.1 would make sense, but I think 4.2 might be a good estimate. I'm going to try that out, see if that works. Let's see, 4.2 times 4.2. Let's see how that comes out here. 2 times 2 is 4. 2 times 4 is 8. I might run out of room here. We're going to put a 0 And we're going to multiply this 4 now times both these things. So 4 times 2 is 8, and 4 times 4 is 16. So I'm going to add this together now. 4 times 0 is 4. 8 plus 8 is 16. 1 plus 6 is 7, and 1 plus nothing is 1. We have 2 numbers after the decimal, so put 2 here. It's maybe a little hard to read there, but that's 17.64. And remember, we're shooting for 18. So we are within 0.5. We're within 0.36 there. So within 0.5. So we don't have to guess again. 4.2 is a good estimate. So 4.2. And we're going to try to find that on the number line now. But remember, oops, I almost forgot. It's our negative 4.2. Okay, so I almost went right to F here, but that's not correct. It's negative 4.2. So we're going to go to between negative 4 and negative 5, but closer to negative 4. So it's B. Okay, last one is number 6 here. We're looking for, on the number line, the best estimate for the square root of 34. All right, since we just did guess and check, let's change things up here. Let's use the long division method for this. So we've got 34. And the 2 square roots are 25 and 36. Square roots of those. The square root of 25 is 5. The square root of 36 is 6. So it's going to be between 5 and 6, 5 something. And we're going to write a fraction this time for us. Remember, for this method to come up with a fraction between the smaller perfect square and the number we're taking the square root of in the problem is the numerator there. So, excuse me, 25, the difference between 25 and 34 is 9. And then the difference between 25 and 36, this distance between the 2 perfect squares is your denominator. So in other words, we're 9/11ths on our way to the next perfect square there. So let's go ahead and change that to a decimal using long division. So we've got our numerator on the inside, denominator on the outside. Our whole number is 5. Let's put some zeros here. Okay, 11 goes into 90 8 times. 8 times 11 is 88. 90 minus 88 is 2. Bring down a 0. 11 goes into 20 just once, because 2 11s would be 22. So we multiply that back out and subtract, and we're left with 9 here. So 5.81. So we're between 5 and 6, but closer to 6. Again, 5.5 would be exactly halfway between. 5.8 is pretty close to 6 there. So let's see what we got. We got between 5 and 6, but closer to 6. Looks like G is our best option there. All right, we'll do some more in class. You guys have to do some more of these on your own, but hopefully that gives you a good idea of what we're working with on this lesson. And we'll see you guys in class for this one.